Good evening, everybody. I'm really happy to have the opportunity to share with you a couple of information from my research. About the pool we just had, I'm more at level 000 about quantum computing. You are all much better than me about the subject, but I'm working from the business part. And I'm an analyst, industry analyst since 25 years, so about business intelligence, big data, data analysis, all these things. And since 2 years, I'm working on quantum computing and on the impact of quantum computing on enterprise technologies. And that's the subject of Contango, which is a website about the impact of this new kind of technology on software platform, on investment in companies. We are absolutely not talking about the academic part or about the research part. We are really talking about the bridge between corporation and academic and startup. This is the idea of Contango. What I will share today with you is a couple of a kind of panorama about what we see actually in the collaboration between quantum computing and academic and research and corporation. And what we see is two different worlds who begin to shake hands. They begin to shake hands because they understand that they need to work together. And it's a very interesting moment because we have people from the academic, which are more working on research and perhaps discover things, and they are not always very business oriented. And on the other side, we have large corporations which are only interested about return on investment, about short and medium term, and they don't really understand why they should invest in something that will perhaps bring some results in 5, 10, or 15 years. And it's interesting because we have really this bridge and people are moving from each side of the bridge and they are beginning to share information and to work on real projects. It's the idea of this panorama, which I'm doing since a little bit more than 1 year. And I collect information from public and non-public source about quantum computing projects in all parts of the world. And I try to compile this information. And I decided to focus on quantum computing. I'm not really talking about quantum sensors and quantum communication, sometimes a little bit, but I try to focus on quantum computing. If you look at the map, it's not the complete map because in the research actually we have more than 100 projects, but we see that we have projects in large corporations in all the north part of the world and Australia, of course, but we have two parts of the world which are not actually ready to really work with quantum computing, Africa and Latin America. I don't speak about research, I don't speak about academics, because we have academics in Africa about quantum computing, we have in Latin America. But actually, I'm not aware of large companies in Africa or in Latin America developing some proof of concept about quantum computing. Perhaps it will come. I think that especially for Latin America, it's a little bit sad because it's an opportunity for them to embrace this new technology and perhaps to close the gap with other parts of the world. So I think they should focus more on that. But if we look at the north part of the world, we have a lot of projects in US and Canada, of course, but we have a lot of projects in all countries of Europe. And of course, we have a lot of projects in Asia, in Russia, in Dubai. There's a lot of things, very interesting things. We will go with this presentation a little bit around each part of the world. But I will present it by industry. And I will begin with public sector. We have a lot of things in US about public sector, but I wanted to share with you some interesting project in Europe. Of course, perhaps that the virus that we have actually could change some priorities, but there's a large project in Europe about a quantum communication infrastructure that it's planned to give in the next 10 years a real infrastructure of communication across Europe for governments, for startups, and for large companies, and to have a real backbone of a European quantum internet. And there's a lot of millions to finance this project. And it's interesting because actually it's working with 7 countries, Belgium, Germany, Italy, Luxembourg, Malta, Netherlands, and Spain. We don't have France in this project, but I'm sure that we will begin with the 7 and it will be extended to all the European countries. It's about the public sector. The finance industry. It's certainly the industry where we have more use cases. There's 4 main use cases that are developed in different banks. I would say that the most important, the most critical is of course cybersecurity. And actually I begin to see some banks which agree that they are already late about that. Why already late? Because we know that a big bank needs 8 to 10 years to change an infrastructure. And actually, we think that thanks to quantum computing, perhaps in less than 10 years, we'll have some very big problems of security in all the cryptographic part of RSA algorithm, all these things. And I think it's a real problem for banks because they need 2 to 3 years to choose a technology, as they need 5 to 7 years to deploy it in all parts of the enterprise. So actually, you have people in the banking industry which say that actually the big banks are already late in choosing and testing this kind of new technology. There's another interesting thing about fraud detection. Fraud detection is all a question of speed, and if you can really change the way you detect this, you can dramatically change how a bank can work with credit card and work with all this electronic transaction. And there's a big money to spend here. If we look a little bit at different banks, we have an interesting case in ABN AMRO in the Netherlands. They are working with QTech, which is a company created by a university in Netherlands, and they are working on a quantum communication network that will help them to connect all their terminals, all their the terminals, point of sale that you use in all shops, and they want to connect all this to a quantum computing proof network, and they are working on that since a little bit more than 1 year. We have an interesting things in Canada with Bank of Montreal, BMO. They work with Xanadu. Xanadu is a very interesting company because it's one of the first company working only on quantum computing software. And it's interesting when you look at the evolution of traditional computing from the 14 to actually, we see that the traditional computer began with people like IBM creating the hardware, the software, providing the service, providing sometimes the people, honestly. And actually, we see that they are trying to do the same. And we see Xanadu, which is one of the first to say we need really a real different software market, different from the hardware side. And they are working with Bank of Montreal, and they are working on the same project with a competitor of Bank of Montreal, which is Caixabank. And they are working to calculate, you perhaps know something called the Monte Carlo method, the Monte Carlo algorithm. It's a way to calculate the pricing of financial instruments with a lot of variables and with a lot of options, and you have to calculate it very fast to see how the price will move in real time. And actually something that is very time consuming with traditional computers, and Xanadu is focusing on that and doing some proof of concept for BMO and Scotiabank. It's a little bit the same, but we have with a proof of concept at Caixabank. Caixabank is working on this idea. It's interesting because they had a project which was to verify if there's a quantum advantage. And actually, they found that there's no quantum advantage, but they find the result that the results between traditional computing and quantum computing were identical. And it was very important. It was the first step to be sure that tomorrow they will be able to use this kind of software on quantum computers to have the result very, very quickly. But actually, they didn't demonstrate the quantum advantage, but they demonstrate that they can use it and obtain the same results than with traditional computers. In US, JPMorgan is working on a little bit the same project, which is calculating a lot of simulation, of Monte Carlo simulation, and reducing from several hours to a few seconds. And of course, if you are able to calculate these things in real time, you will be able to take some options on the market more quickly than your competitor. So it's something interesting. We have a lot of case study in finance. In all countries, there's Nomura in Japan, there are BBVA in Spain. There's a lot of banks, and in each country you have one bank working on quantum computing projects. Another interesting industry is transportation. Of course, Airbus. Airbus is perhaps the largest company to communicate a lot about quantum computing. They organized last year a hackathon to make people work on their problems, and they have interesting problems like the optimization of fluid dynamics to optimize the design of what they call wing boxes. The wing box is the part between the wing and the fuselage, and it's a part where you connect the wing with the fuselage, and it's a place where they really need to optimize the dynamic of the fluid. And they need quantum computing for that because they don't have the enough resource with traditional computer. So, and Airbus is working on a lot of projects about quantum computing, air traffic optimization, the idea of modelizing an accident, and working on all the data from all the sensors very quickly to understand what kind of scenario can create this kind of accidents. So there's a lot of projects in Airbus working with quantum computing. In the automotive industry, We have a lot of projects, BMW, Volkswagen, Mercedes. There's a lot of people working on that. With BMW, it's interesting because it's not about autonomous car. It's part of the project, but the main project about quantum computing is the optimization of robots, painting robots and welding robots. And they explain that it would take years to calculate all the options of the path for welding robots, and it would take years if they calculate that with a conventional computer. And actually, they are working on this kind of optimization with results in a couple of seconds. So it's something very interesting to see that it's quantum computing is touching automotive industry, but not only for autonomous cars, but for the manufacturing part. And it's the same with other companies like Daimler, Mercedes-Benz, all this. Another interesting option in transportation is the shipping industry. There's a regulation that will change this year, and that will reduce the level of sulfur that can be created by the shipping industry. And this company calculated that using this kind of optimization software can help them to save $1.3 million per year and per ship. And you have 50,000 ships in the world, this kind of ships. So it's very interesting to see that if this kind of project is working well, and actually it's working, it's using the Fujitsu technology, which is not a native quantum computer, as you know, but this kind of software developed by Fujitsu is using quantum computing technology to optimize the oil consumption of this kind of big ships. And there's a big money behind that. In Russia, they are working on a quantum network using 70,000 of kilometers of fiber optical network, and they want to create a national encrypted network. Of course, we are talking about Russia, so it's very connected to the government. It's a project of Russian highways, but of course it will be used by government to create a secure communication network inside the country. Volkswagen, like BMW, like Mercedes-Benz, is working on quantum computing for manufacturing, and they launched a project, an interesting project, during the last Web Summit in Lisbon. It was a quantum-powered taxi application. The idea was to optimize the position, the number of taxi, bicycle, buses inside the city in real time, depending on traffic and on the number of people who want to take this kind of vehicles. So we don't have a lot of returns on this project, but they succeed in launching that last year at Lisbon conference. In the strategic and military area, we have a lot of projects too. We have a project in the French army, which is to use not only quantum computing, but quantum sensors and quantum communication of course, to create some protected network, but say imagine other application like using entanglement to see things. I'm not sure I understood everything, but the idea is to see someone, someone behind the wall, or to see the enemy behind a mountain, and it's something they want to try with quantum technologies. And they put some money on it, but mainly with French companies like Atos. Atos is a French company which is working on quantum computing with a simulator, and perhaps tomorrow with something more native. But actually, it's a project financed by the French government. I know that you have in US a lot of military projects about quantum computing. For example, the Defense Science and Technology Laboratory is working on this kind of technology, and a little bit the same than the French one, to use quantum sensors and quantum communication to be able to collect information even if you don't really see the objects. In China, there's a lot of quantum computing projects in China. There's one little bit more public project, which is a fiber optic communication network. Actually, it's working with 2,000 kilometers of fiber, of optical fiber. And the idea for China, they say that they will no longer be spyable within 2 years. And interesting, they explain that they have been motivated to launch this kind of network by Edward Snowden's revelations. And of course, there's a lot more in China, but and we know that China Army is working on quantum computers, but there's not a lot of public or even non-public information. In healthcare, there's a lot of simulation problems in healthcare, and we have this case, which is interesting, which is a case which this case will help to reduce the necessary time to understand if chemotherapy treatment work or not. And they say that they can reduce from 6 months to 1 week the delay they need to know if the treatment is working or not. So, of course, it will help to adapt the treatment to the patient. Another interesting thing about that is that they are using Microsoft, and as you know, Microsoft is not actually doing a quantum computer, but they have created a software environment that will help people to begin to work on quantum algorithm that will be able to work on the future quantum computers. So it's interesting because from this university, it's a way to begin to work on real projects without having the real computers and being able to prepare the software before running it on the real computers. Merck is working on the same, and the idea, and perhaps they are working on the virus actually. The idea is to reduce the number of molecules that you will test on human, and because you have done a lot of simulation with quantum computers. In the energy part, it's interesting too. We have a very interesting project in Dubai. Dubai is a place where you can find all the environments to develop quantum computing. People of Dubai are very, very intelligent. They have a lot of money, and they are searching for the next step for countries like Dubai. And quantum computing is something for 5, 10, 15 years. When we know that petrol and oil will not be available like today. So it's something on long term, and it's something that need a lot of money. So quantum computing is a key innovation program for Dubai, and if you want to find some money, there's a lot of interesting things in Dubai, and you can look at this kind of program. The Dubai Electricity Network launched a kind of sponsorship program to detect new startups that can help about the power, but that can help to create some quantum computing infrastructure in the country. There's another project in Germany about the simulation. It's the idea to predict in real time when power is needed in a specific area, to be sure to adapt the supply to the demand. And as I said, that actually, if you want to predict that with all consumption of every people in the country, it will use billions of variables, and it will not be able, they will not be able to do it with traditional computers. In Russia, again, in Russia, there's an organization. I'm not sure it can be called a company, Rosatom. Rosatom is the branch of the government which is working on nuclear energy, and actually they have been commissioned by the Russian government to develop quantum computers. We don't have a lot of information about that. They communicate a little bit, but there's not a lot of verification about that. But for sure, they have been funded by the government to create some computers that will be used by the other agency in Russia to develop software. And in France, we have in the energy sector, Total. Total just announced yesterday or 2 days ago that they are working on the CO2 capture with quantum computing and with quantum algorithm created by Cambridge Quantum Technology. To be honest, I don't understand nothing to what is a nanoporous material, but they explain that with this kind of technology, they hope to be able to simulate how the material can absorb the CO2 and elect which kind of material they have to develop to trap the CO2 that they are generating and the CO2 from the air. So it's a very interesting project. Perhaps as a conclusion, what I wanted to share with you is that this panorama, we have more than 1,000 projects in the global panorama, not 1,100, sorry. 100 projects, 1,000 will be next year. 100 projects in the panorama, and all these projects, we see that there's this idea of a bridge between research and enterprise. And people need to understand how the other part want to work. Enterprise need to understand that you cannot buy something. Actually, you can buy artificial intelligence, you can buy big data, you can buy a lot of things. You cannot really buy something in quantum computing. So you have to invest and to participate to the creation of that. And so the company we are talking about are ready to do that. And on the other side, we have startups, we have research labs, we have academics, and they have to understand that it's not only for the pleasure and the beauty of research, but they have to create something that will be useful for companies. And you have to meet the company in the middle of the bridge, and I think it's all the companies we are talking today, we are talking about, they are in the middle of the bridge, partnering with startups, partnering with academics to create something not only for the research part, but to help companies to grow. And if you are a startup, I think it's very interesting. It's a very interesting moment because you can not just do your research, but you can identify problems, real problems that can't be solved actually, but that could create value for your company. And if you are doing that, it will help you to find money, because the investors will be very interested by this kind of partnership with large companies, and it will be the best way for your startup to grow and to go in the right direction to create money. So what's a couple of things I wanted to share with you. I know that you are much more competent than me about that, but I think it was interesting to have this global overview about what is happening in the world.
Fabulous. That was really good information. Thank you very much. Any questions, people? If not, I'm going to start asking my questions. I got a boatload of them.
I'm afraid of your questions.
Yeah, they're shy, but once I get rolling, they're in a superposition state. Should I or should I not? Well, let me and if you'd like, I think we've got a small enough group here. Verbal questions would be great. So just raise your hand or somehow notify me that you want to talk, and I'll unmute you. While we're waiting for that, first of all, I mean, your insight is really, really good, I must admit. I come from the investment bank world, and this is definitely investment banking material that you're, really high quality research that you've done, and the insight that you give is fabulous. So thank you very much. This is really valuable information. So one comment about Dubai. I'm a big fan of Dubai, so take those words seriously. That's a very progressive environment there, business-wise. There's boatloads of money. It comes in from all over the world. So that is an interesting hotspot. So I appreciate that some of the pointers on Dubai. I do have a question here. Wait a minute. From John. Thanks for the overview. Very interesting. Can you draw, this is for you, Philippe, can you draw any conclusions for large enterprise workforce? Do they need quantum PhDs in order to implement the applications you discussed? Very good question, John. Near and dear to my heart.
Actually, I'm not seeing a lot of large companies investing in people. Perhaps not enough, but actually they think that it's a little bit early to invest in this kind of people. So they invest more in partnership with academics and with startups. And in the list, we have a lot of examples of large enterprise working with academic research. And I think it's the best way actually, because I'm not seeing a large company hiring a lot of PhD working on a technology that will be mature in 5 to 10 years. I think it will be a little bit early. I think not, but I think actually we see in large companies IT people, young IT people, interested to give a little bit of perspective to their career, and they don't just want to do deep learning during 30 years. They are young, they are 25, 28, 30, and they want to take the next wave. And I see actually a lot of young people working in large companies and going back part-time to university, perhaps to do a quantum PhD, and they will bring to the company this kind of knowledge in 2 or 3 years.
Yeah, if I can add my 2 cents to this, this question's dear to my heart, and this is really what I'm focusing in on at Harrisburg University is, I'm making the statement by what we're doing in the programs that we're putting together, that is, the statement is that to be productive in this industry, you don't need a PhD necessarily. Now, today, a PhD is what most people are looking for. And correct me if I'm saying something you're not finding as well, Philippe. But today, sure, they're looking for PhDs because we're still very much in a hardcore research environment. Assuming, if I may, the PhDs do their job, both on the hardware and the software side, we'll be moving out of this research environment, this research posture, to more of a production mode. And that's really what I'm trying to position our community and our ecosystem for, getting into that production mode where the numbers of people who are able to talk about quantum computing and understand it and respect it, while not needing a PhD to conduct original research, will grow dramatically. And so, you know, for all of our friends out there in the audience, you know, I'm convinced you don't need a PhD to do this work productively. And I have a PhD, so I can say that without a shadow of a doubt in my mind. So that's what these programs are all about. The argument is you don't need a PhD. PhDs train you for doing original research. And, you know, in 4 or 5 years, hopefully, there's going to be a need for non-PhDs. That's my 2 cents. Anyway, getting back to questions, here's another question. Besides research projects and early proof of concepts, did anyone come to the level of putting something into production, even for a very trivial use case? Thank you. Merci.
I don't think so. Actually, we have only proof of concept. We have proof of concept that succeed to obtain our results, but we are not in the deployment part. I see 2 reasons. Maturity of enterprise. Actually, the enterprises are not mature enough to really understand how they can add this component inside their IT architecture. And secondly, because I think that the vendors, IBM, Microsoft, and all the others, they are not really mature enough to really provide something for production environments. So I think that actually no, but perhaps in 2 to 3 years, we will see a first project in production.
It's so we're all getting ready for 2 or 3 years or N years out. So cool.
Yeah. It will depend on maturity of enterprises and maturity of IBM and the others.
Thanks, Philippe. Another question. You might have mentioned these use cases, and I may have missed. A word on energy companies using quantum computing to optimize electricity demand and estimate materials. Electricity generation stations, which come to mind for one case, France, EDI, I believe.
Yeah, it's EDF, Électricité de France. It's the main French electricity company. Yes, they have a project. They have a proof of concept running actually, but I don't have information about the success of this proof of concept. It's a little bit the same than Innogy, which is a German company based in Essen, and it's a demerger of the big electricity company of Germany, and they use quantum computing to predict in real time when the power is needed in a specific area to balance supply and demand. So it's a little bit the same that we have in France with EDF, but I don't really actually have any sign of success. That's it.
Merci. Another question from Sarita. Will IBM or Microsoft provide infrastructure free to businesses to do proof of concept using quantum hardware and software to build a case for business to fund the projects?
That's a very good question. I would like to have the answer. It's like a top secret information. Top secret information because IBM and Microsoft and all the others need to sell their tool, especially IBM, which is creating quantum computers. They have to sell it, but to sell it tomorrow, they have to prove that it works, it's working. So I think that actually, if you are one of the big companies in the world, you will have access to IBM infrastructure for free if you have an interesting project. I think it will be case by case. And but if you are a very small company and if you don't just want to try it, you can join IBM program. And if you are selected, you will have access to IBM quantum computer. But it will depend on the potential for IBM. I think so.
I'd certainly will like to add to that. I mean, you know, I do give IBM a lot of credit for at least making, you know, 5 qubits available to us in the public, and you know, they're kind of like giving us a little bit of candy, if you will, but clearly you can't do any real business level proof of concepts there. But you know, I'm happy for that, frankly. Otherwise, we wouldn't be, you know, us in the community wouldn't be able to move along there. But you know, what do you think about? Do you think the AWS and Azure opening up their cloud ecosystem environment to quantum computing will move the needle in any meaningful way?
Yeah, because I think that all agree that we will not have a computer. We will not have a quantum computer in house. It will be on the cloud. It will be available on demand, exactly like traditional computer in the 50s, the 70s. It will be exactly the same model. So you will pay for the usage of it. So cloud is perfect. And I especially love what Amazon is doing. They don't try, perhaps they try on the other side, but they don't officially try to develop their own quantum computer. But they want to be the interface, the platform. Behind that, I will have access to all quantum computers of the world. And I think it's a genius. It's exactly like it has to be during the next 10 or 20 years.
Thank you. Well, with all due respect, Philippe, you know, I am, if you can see my video, I am in my basement, and there is a quantum computer on my shoulder. So us consumers do have access to it, at least a virtual picture that we can toy with. Anyway.
No. What I say is that actually the technology is changing so quickly that even if I am a very big company, I'm not sure I will invest in a quantum computer just to try it. So it's the idea. I think that the cloud is perfect. So there are some clients of D-Wave in the Army, in Los Alamos laboratories. They buy all D-Wave computers, but it's an exception.
I would add, you know, and I don't have definite proof of this, but I would imagine some of those early users of some of those devices have very significant social ties to D-Wave, for example, pre-existing, you know, because the, you know, as you're saying, the business case, you know, isn't necessarily there yet.
Yeah.
It's something for me to investigate over the coming months. Anyway, hi Philippe from Alex. Thanks for the presentation. Have you been also tracking the progress of quantum computing capabilities and milestones? Has there been any more useful quantum supremacy examples since Google? Examples where quantum computers are doing better than classical computing?
To be honest, no, because I'm not very interested by that. I think for me, from my point of view, when I stay with a chief information officer in a very large enterprise, they don't care about this race. They are laughing at these young people showing their tool and comparing their tool in college, and they don't see that like something very serious. So actually, we don't have measurements, we don't have honesty between the both, and it's not so important. Quantum supremacy will come. It will be this year, next year, in 5 years, who cares? If I have a project, I want to demonstrate that I can calculate something more quickly with a quantum computer. When it will be available, what I need is the results. I don't care about it if it's with Google or IBM. So I think this topic is very inside the community. But for an enterprise, it's not so important.
Yeah, I mean, that's the thing that, if I may, us out here in quantum computing land, in the ecosystem, we need to, first of all, recognize, and it's very hard to recognize the fault line, if you will, between businesses, the way businesses think and the way academics or curious people like us think. There's a huge fault line there, in that, you know, I agree, they don't care a bit about quantum supremacy on the business side. You know, they look for, you know, business advantages. And that's one thing that we need to learn on our side, to really respect and appreciate and work with, rather than ignore and work around. Okay, another one. You got quite a few coming up here, man. I better shut up. I'm going to just fire them at you. At QRECA, which is the Quantum Resources and Careers, we are focused on creating this quantum workforce. We do not target PhDs, but anyone interested in working in quantum technologies for a specific sector. What is important is to identify the skills needed for the specific job.
Yeah, that's not a question, but you're right.
Yeah. Araceli, if you wouldn't mind putting the link to your center in the chat, I certainly, for one, would appreciate it, and others might as well. It's good.
Yeah.
You're preaching to the choir here for sure, at least in me. Next one, thanks for the great presentation. Do you see any convergence as an industry standard happening on underlying quantum computing technology for qubits? Electronic spin dots, NV centers. This is sounding a little technical here, but what are the implications? From Garesh.
I would say that when you cook something, sometimes it's better when you wait a little bit. Don't rush the fire. Your question is very interesting, but I think it's a question for perhaps in 2, 3, 5 years. We don't really know. And if we remember the video recording market, you remember that we began with Betamax, VHS, V2000, all these things. And at the end, staying only VHS. And but the market needs time. It's like cooking. You put the ingredients, and sometimes it's better when you cook 3, 4, 5 hours with a little fire than trying to cook it very quickly. So I think your question is very good, but I think it's a little bit too early.
Okay, coming from Australia, very insightful research, Philippe. These are all really large projects. Are there any solutions for SMEs, small, medium enterprises, using quantum cloud services, for example?
I think that not yet. Not yet, because when we talk about this project, very often I talk about one large company, one large hardware vendor like IBM or another one, and a software company, a software startup focusing on quantum algorithm, like Xanadu, like quantum coverage technology, all these things. And these kind of startups, by the way, it's interesting because actually you have some investors specialized in quantum computing and specialized in quantum software. And they are financing this kind of small startup. When I say small, it's startups from 3 to 10 people. It's very small organization. So they have to focus. And they have to focus on large projects where there is money. So actually, again, it's too early to create an offer for small businesses. I don't know a small business that is able today to pay the same than a large company And so I think if we come after that, it's like all the software history. ERP have been created for very large companies. SAP have been created in the 70s for a large company. And after that, step by step, you go to small and medium businesses. So I think it's a little bit early for that again.
Well, and I may just be rehashing the same answer, but you know, with opening eventually when AWS and Azure, and rumor has it, you know, by the end of this year, when they actually open up their services, do you to give us access to multiple hardware devices at a reasonable cost, maybe, probably, hopefully, do you think that will catalyze some budding entrepreneurs out there to you know, really start taking a look at quantum computing as a business? You know, I mean, really small shops, because, you know, they basically have essentially zero fixed cost when it comes to access to hardware. You know, and right now, you know, IBM won't play with an individual, and another will D-Wave, you know, give them access generally. Do you think that that will catalyze, and if so, to what degree, or why not, you know, the small individual entrepreneur?
It's interesting because actually the founders of this kind of startups are coming from the research and academic part, and they are going out of the academic to create the startup. So it's people mainly that are not very involved in the business and the sales and marketing side. It's interesting when you look at their presentation because they are researchers. They are not salesmen, and it's interesting because they don't like salesmen, and salesmen don't really like this kind of geeks talking about how quantum computing can work, but not able to talk to large enterprise. So it's interesting, the idea of the bridge I was talking about before, because it's a bridge between people too. People from experts from quantum computing need to understand the business part of a market, and the old sales guy from the software market need to understand that there's something new, and it could be perhaps interesting to integrate this kind of new technology and sell it to the large companies. I think it's a bridge between people too.
Interesting way to think about it. Thanks. Okay, it looks like the questions are drying up. If you allow me to cover one more question for me, and then a statement, if I may. What do you think about the governments, the space race, if you will? You know, we've got India pumping in money, the UK, obviously, China, United States, a few other smaller countries starting to pump money into the ecosystem. Do you keep an eye on that, and do you think that will have the you know, the outcome of fueling business, entrepreneurs, risk taking, et cetera, in this space?
Yeah, I think it's very interesting because I'm from the business side, and for me, a government is a kind of business. And when I look at the announcement of billions that you put on the table, for me, it looks like marketing. Trump and the others are doing their marketing, talking about the millions I will put on the quantum computing market. It's the idea to say, I will be the first one because I put 1 billion, I have 2 billion, I have 3 billion. It doesn't have any sense because, yes, of course, it's a question of money, but it's not only a question of money. And you cannot buy everything. You can try to buy people, you can try to attract people with money, but it's not enough. It's not just money. And actually, we know that US will be on the top, China will be on the top too. Russia, it's difficult to know because they are more secret than China, and it's very difficult to know if they will succeed in something. Europe, I don't speak about France and Spain, because if we continue to invest in each country, it will not work. If Europe is doing a package, it can be on the podium. But after that, when you have a press release from an African state that saying that it's creating a quantum computing valley to be the number one about quantum computing development, yeah, it's funny, but honestly, it will not work. It's not just a question of money.
I'm speechless. It's not a question of money. I've just spent 20 years trying to figure it out and concluded that it is all about money. But seriously, you know, I was talking to a person in the government a few months ago, actually, and somebody close enough that would know. The interesting thing that we need to watch out for is that, you know, when these governments make these big broad claims that we're going to invest $1 billion in quantum, there's actually, you know, at least in the United States, there's a process that needs to occur till that money actually gets put out into the system. So, and in China, I know they make a lot of grand announcements all the time, and they actually that money never actually gets to the ecosystem because the money just never appears. So that's one thing for all of us to keep in mind. If a government says, oh yeah, we're going to pump $1 billion into it, you know, as people in the ecosystem, we really need to check up on that and watch for that, because that money, that announcement doesn't necessarily mean that the money actually even goes out. And I'm not talking about the efficiency of the money. I'm talking about it just never gets approved in the United States in Congress or what have you. So, you know, watch the headlines on that. They don't always necessarily mean anything more than, as Philippe was saying, you know, bragging rights or some competition that the politicians are playing on. Anyway, so I think that's it on the questions. Philippe, thank you very much for your time and energy. And again, I'll stress, this is really, really valuable information, folks. And I might add, you know, the slides, thankfully, are available on the site, so to take a look at later. On a individual level, this looks like a very good listing for job outreach. You know, when we move from the beginner or intermediate level in the poll there and get more expert, et cetera, and we start to want to, you know, look for jobs and such, these companies that Philippe mentioned might be, you know, some of the first companies on our hit list for doing some deeper research and actually, you know, doing some outreach for some work. I don't think it's appropriate to say Philippe sent you. Would you agree? But I mean, this is a wonderful hit list or target list.
Yeah. I would love to share a lot more, but it's always difficult because we are a private company and we cannot share everything on open source. We have to work with clients too, and but you can begin with that.
Of course. But yeah, I mean, this is quite generous. This kind of the research behind all this and the time and energy to put together a presentation like this is tremendous. So thank you very much for sharing what you have shared. And I'm just suggesting our community take advantage of that. And if anybody gets a job in any of these companies, be sure to send Philippe a thank you note at a minimum. So anyway, I think we'll close it here. Philippe, you were talking about a 30-minute event here. Look at this. We're looking at over an hour. So you're just really good topic. So.
And we still have more than 20 people. So I think it's interesting for everybody.
Yeah, indeed. Yeah, we went past the 1 o'clock mark, which tends to lose them just by structure. But the recording's available, and thank you very much. What can I say?
Thank you. And I hope that everybody will find their route on the quantum computing story. It will be very interesting for us.
Thank you very much. All right, folks.
Bye.
We'll see you at the next event. We've got one tomorrow at 3 o'clock. Another Frenchman. Boy, this is France week here in Quantumapalooza. Anyway, so thank you very much. We'll see you around next time.